I would write W plus 6, W minus 2. The sum is indeed 6, and the product is indeed negative 12. So W equals negative 6? No. And W equals 2 feet? Yes. If W is 2, how much is L? If W is 2, how much is L?
Six.
That's it. The product is 12. So this is it. That's all I needed to determine. How many solutions does a contradiction have? Contradiction. Or, which I don't agree with, but I will use it because the book uses it, inconsistent. How many solutions does a contradiction have, or an inconsistent equation? Anyone?
No solution.
Exactly. What about an identity?
One solution.
Infinity, right? Many. What about a conditional? You can say 1, you can say 2, you can say 3, but in other words, finite. Not infinite and not no solutions. I can list them all. I'm able to list them all. This equation is conditional. It's true for these two solutions. This equation is conditional. It's true for these two solutions. And so on and so forth. But finite. I'm able to list them all. Here, I'm not able to list them all. They're all infinite. Here, no solutions. Perfect. Okay, back to our list of topics. I think we had enough of word problems. If we have time, we'll come back to more problems, but I'd like to touch up on anything else that you want to.
Can we do graphing?
Yes, you mean graphing a linear equation?
Yeah.
Okay, graphing a linear equation, so perfect. Or a linear function, perfect. So here's a very simple example. Let's say 2x plus 3y equals 6. When x is 0, how much is y? Perfect. What is the ordered pair that we just determined?
No, 2.
Perfect. When y is 0, how much is x?
3.
Perfect. What is the ordered pair that we just determined?
3, 0.
Perfect. That's all I need. That's it. 30 seconds. 0, 2, 3, 0. Done. I don't have anything else to say. Write the equation. Done. Anything else? This, we've been doing it all the time.
Absolute value inequality.
Yes. Remember with absolute value inequalities, we have two types. We have the chain and we have the union. So two types, type 1, type 2. Chain and union. So here's for the chain. 2x plus 3 in absolute value less than 2. For the union, 2x plus 3 in absolute value greater than 2. Well, let's also put the equal symbol here and not there. Doesn't matter. This one is a chain. Negative 2 less than or equal to 2x plus 3 less than or equal to 2. Do not separate this one, because then you get into trouble because you have to intersect the solutions. So you subtract 3 from all three sides, and you divide by 2 and you're done. And you have to write the interval notation. Simple. This one requires more work because it's not the chain, right? So here I have 2x plus 3 to the right of 2 outside, and 2x plus 3 to the left of negative 2, the outside. This is the inside, between negative 2 and 2. But this one, that's why it's more difficult, because it's the outside, meaning to the right of 2, left of negative 2, not 2, because you will include this one. Be very careful on this. So here I have 2x greater than negative 1 and x greater than negative 1/2. And here I have 2x less than negative 5, x less than negative 5/2. It's the same thing, but the sides with the union. This one first, negative infinity to negative 5/2. And then this one, union, negative 1/2 to infinity. See the difference? This one is inside, that is not here. And this one is the outside.
Okay, so this is the part that I got confused when it says that negative infinity and then negative and then
Because this one says to the left of negative 2. Everything to the left of negative 2 starts at negative infinity and goes to negative 5/2. This one says everything to the right of negative 1/2. It starts at negative 1/2 and goes to infinity.
Okay.
It's not difficult, but it needs practice. I make it look easy, but we need time to think about it. But I'm trying to give you the explanation so it's as easy as possible for you. That's it. There are only two types of linear inequalities. One that is a chain, straightforward, and the other one that is the outside, to the right of 2, to the left of negative 2. So we talked about linear, we talked about radical today, we talked about rational last time, but if we need more example, and we talked about simple polynomial with factoring. No, the substitution rule, no. I did not, and I will not put at this point the substitution, just simple factoring by grouping, like we just did a few minutes ago. So factoring should not be a problem, but I'm crossing these out, but it doesn't matter. You can choose anything. Let's look a little bit at reading from a graph. I like to do that. And then you can choose the next topic.
When you're done with reading from a graph, can you go back over the union stuff?
Yes. Here?
Yeah.
Yes. So which part is not clear here? Or you want to look at another example?
Can we just look at another example?
Oh, yes, of course, of course. So let's look at another example and then we'll go to reading from the graph. because we're here and page 13. Do you want to give me a problem, or you want to make one up, or you want me to make one up, or?
Can you make one up?
Yes. So let's say 2, the absolute value of x minus 1, minus 7 greater than 3. What will be the first step towards solving this absolute value inequality?
Absolute value by itself. I had 7 first.
Of course. Brilliant. Thank you very much. What will be the next step towards cleaning it up? I'm not ready to convert it into something else. I have one more step to go.
Divide by 2.
Exactly. So then I have the absolute value of x minus 1 greater than 5. So right here, I'm going to write x minus 1 greater than 5 to the right of 5, and x minus 1 to the left of negative 5. Make sure you don't include anything. You cannot include anything between negative 5 and 5. You have to find to the right of 5 and to the left of negative 5. So this one means x greater than 6, and this one means x less than negative 4. So if it's easier for you to see what's happening here, let's graph it first. To the right of 6. To the left of negative 4. Negative infinity, negative 4, union 6 to infinity. Graph it first if it's easier for you to see. Is this better?
Yes, thank you.
My pleasure. Okay, I want to read from a graph. Okay, so here's a graph. I'm going to enlarge it as much as I can. So let's look at the blue graph. If I am asked to find the percentage for alcohol in 1995, I'm also going to graph something on paper in a minute. So let's say the question is asking me find the y value of the blue graph, which represents percentage, for whatever the problem is about alcohol, I don't care. For 1995, I imagine I draw a vertical line. I see where it crosses the graph of the blue graph, and then I will be reading the y value. I will estimate it roughly at 54%. That's one type of question. What if they ask me now, find for the red graph or purple graph, find in which year the percentage for the red graph or purple graph was 30%. Then I will come with a horizontal line. I will imagine that I draw a horizontal line through 30%. I see it crosses the graph in this point, and I'll say, oh, it happened in the year 2000. I want you to be able to read from a graph. So here's an example. So let's say I have this graph. That's my graph. So this is the function or any graph. And let's say I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm asking first question. If x is 2, find f of 2. What will you say? You will draw through x equals 2. You will draw, or imagine you draw, x equals 2, a vertical line, and you will be reading the y value. In this case is 3. So when I'm given x, I draw a vertical line, I see where it crosses the graph, and then I read the corresponding y value, which is 3. However, I may be asked the other way around. If f of x is 1, find x. In this case, they're really giving me the y value. So I draw, or imagine I draw, a horizontal line y equals 1. F of x or y are the same thing. And I see it crosses the graph in one point. And I will be reading the x value. So I'm going to estimate here 2.8. So x equals 2.8 when y is 1. Very important to be able to read from the graph. That's what I mean, reading from a graph. And later on, we're going to look at domain and range and so on and so forth. So we should be able to read from the graph. Okay, anything else? What else would you like to review? We can review anything you want. Order of operations, again, rational, radical, linear, polynomial equations, anything you want.
Can we go over polynomial equations, whichever
Yes.
one you want?
Yes, let's go over polynomial equations. And also, of course, there may be one y value or maybe more than one y value. You just have to draw the horizontal line and see in how many points the line crosses the graph of the function. Okay, so we want to look at polynomial. Very good. So which page am I on? I'm on page 14. Good. So allow me to choose any polynomial, rational, because I don't see any other problems in there. Let's see if I find in here. If not, I will find in here other examples. Either one. So rational, linear, rational, absolute value. Where are my polynomials here? So choose another example. Rational, all rational, complex, graphs, rational, rational again. Polynomials! Okay, finally I got it. Factoring polynomials, factoring. And he's solving, factoring again. No, not solving, okay, not solving. Rational expressions. I can make one up, but I was just hoping that, okay, finally I got it. Got it. Okay. And polynomials. Here's an example. And I'll tell you where I get these from. Here it is. They are in section 1.6. This is on page 187 from Math 137. Okay, so here's an example. Let's say x plus 1 equals 9, x cubed plus 9x squared. Good. First step. I have to identify the degree so that I know how many solutions I'm after. How many solutions am I after?